Hi, this video is about measurement using measuring cylinders. We know that measuring cylinder is used to measure the volume of a liquid and to measure the volume of an irregular shaped object. Look at the question number 1. Here, if you see the diagram, you can see the top of the meniscus and the bottom of the meniscus, and we all know that if the liquid is transparent, you have to measure only the bottom of the meniscus. So, here, the volume of the water is, the volume of the water is 47. Am I right? 45.5, 46, 46.5, 47. So, the volume of the water is 47. The option is A. Question number 2. Here, there are two pictures. Okay, two in this before and after. Here, there is a volume of water in this first measuring cylinder. Then it is poured into a beaker. After pouring, this is the leftover volume of water. And the question is, how much water has been poured into the beaker? Okay, I'll show you the picture. Look, this is the initial volume before pouring into the beaker. So it shows that it's 115 centimeter cube. After pouring into the beaker, the remaining leftover is 60 centimeter cube. So how much has been poured into the beaker? It is, if you subtract these two volumes, you will get 55 centimeter cube, which is the option C. Question number 3. Here, a modeling clay is inside a small measuring cylinder. Now, when you remove this modeling clay from this small measuring cylinder filled with water, the question says that the volume of the water goes down by 20 centimeter cube, which means the volume of the clay is 20 centimeter cube. Okay, so that is constant. That's not going to change. Volume of the clay is 20 centimeter cube. So, if you're going to take this constant value and going to drop into another cylinder which is having a larger volume, so then the rise in volume is going to be the same 20 centimeter cube, isn't it? So, just because the measuring cylinder is larger, that does not mean the volume of the clay is going to change. So, this second cylinder, which is larger than the earlier one, is also going to show the same 20 centimeter cube rise. So, the option is D. Question number 4. Here, we have 3 diagrams. The first measuring cylinder shows a volume of 50 centimeter cube. The second diagram shows a volume of 60 centimeter cube with the sphere inside the glass ball, okay, which shows us that the difference in volume, like 60 minus 50, is going to give you 10 centimeter cube. So the glass ball is 10 centimeter cube. But the question is, again, we have to go to the third picture. There you have 2 glass spheres and there's a cork too. So the question is, what is the volume of the cork? Okay, let us see the picture in more detail. Look here. So from diagram 1, volume 1 is 50 centimeter cube. From diagram 2, it is 60 centimeter cube. So the volume of one sphere is going to be 10 centimeter cube. Agree? Then from diagram 3, the volume shown is 100 centimeter cube due to 2 glass balls and 1 cork. So look here. So V3 minus V1. Okay, from diagram 3 and diagram 1, we are subtracting the volumes. So we are getting 50 centimeter cube. Understand that in this 50 centimeter cube, we have 2 glass spheres which are of 10 centimeter cube each. So 50 minus 2 times 10 for the 2 glass spheres. So you will be getting 30 centimeter cube. That is the volume of the cork. So the option A is correct. Okay. Now moving on to question 5. Okay, a student investigates the rate of flow of oil through a funnel. Okay, the diagram shows the experiment and the volume of oil in the measuring cylinder at the start of the experiment and 1 minute later. Okay, so here's the initial measurement. Then after 1 minute, there's I think 7p. Yeah. So initially it shows 22 and 70. Let us see the picture in detail. Initial measurement is 22. Yeah, 22 centimeter cube and volume 2. After 1 minute, it is 70 centimeter cube. Clear? So V2 minus V1, which means 70 minus 22 is equal to 48 centimeter cube is the volume of oil that has flown through the funnel into this measuring cylinder for 1 minute. Which means, but if you see the option, they are asking for 1 second. So what we have to do, 48 centimeter cube divided by 60 seconds is going to give you 8.8 centimeter cube per second. Here? Okay. Moving on to question number 6. This is similar to question number 4. Okay, 3 different pictures. You need to find the volume of the plastic here. Okay, so what you have to do? Actually, we are going to use the second picture to find the volume of the metal block, which can be subtracted later. Okay, let us see the picture. Look here. From diagram 1, volume 1 is 55. Yeah? From diagram 2, volume 2 is 70 centimeter cube. So, from 2 and 1, we understand that the diagram of the metal block is 15 centimeter cube. From diagram 3, we have the volume of 80 centimeter cube. Okay, so it's actually from diagram 3, 80 minus diagram 1 volume, which is 55, is going to give you 25 centimeter cube. Understand that in this 25 centimeter cube, you have one metal block which we don't want because we want only the volume of the plastic. So subtract the volume of the metal block. So 25 centimeter cube minus 15 is going to give you 10 centimeter cube. Okay. So the correct option for this question is A. The last one is very easy. Here the diagram 1 shows a volume of 20 and diagram 2 shows a volume of 35. So 35 minus 20 is equal to 15 centimeter cube. Yeah. Thank you. Please like, share and subscribe for more videos. Bye.